So after we graduated from Monte Vista High School in Cupertino, Erez continued on to get his PhD in computer science from UC San Diego. So afterwards, while his peers continued on to research and full-time gigs at Google, Microsoft, and up-and-coming startups, he decided to go the other route. So stick to a story and continue building guitars. 10 years ago, while Erez was an up-and-coming luthier, we were driving up north from Southern California with his first two guitars that he built. And he didn't have any power tools back then. He was intending on gifting one to his guitar teacher, and I had to take the other one. I fell in love with it. It sounded beautiful. So we were his first two customers, basically. And here we are 10 years later, inspiring so many others, Erez and myself, to continue playing our instruments and appreciate fine craftsmanship. So please join me in giving a warm welcome and a big hand to luthier Erez Perelman and my friend.
Hey, thank you so much, Barris, and everyone here. Decided to take time from their work. This is probably a little bit different from what you guys are used to. So I feel privileged to be here, and I hope you guys will find it interesting. The talk, we titled it Art, Music, and Engineering. In a way, it's kind of how I feel about myself. Just three different spaces that got grouped together into what you're going to see in front here, the guitar, which is what I focus my life on today. So let's get started. Barris already mentioned it. I got a PhD in computer science. My advisor has actually recently joined Google, so I'm actually seeing a few of my colleagues from my university years, which is kind of nice. And that was 10 years ago. So let me get started with what we're going to discuss today. We're going to talk about my evolution briefly, how I got into making guitars. Then we're going to briefly discuss the history of the guitar. It's a very interesting instrument. And then we're going to get down to the nitty-gritty of making the guitar, what goes into it, materials, construction methods, working with hands, things that are different from being on the computer, really. And at the end, I really want to leave time for questions. And also, I have a client of mine. He's a fantastic player. This whole talk got organized very last minute, and I asked him if he could do a little video demonstration because he has a flamenco guitar and a classical guitar. So we got a little treat from a great player. I'm going to include that at the end of the talk. Okay, let's start with my journey. As a young kid, I always loved working with my hands. My father did everything with his hands, built furniture and things like this. My grandfather was a sculptor, and he had a small, tiny little workshop in his house, and I loved spending hours there. And as a young kid, I used to just take pieces of chunks of wood I found on the ground and start hacking them with knives and chisels. And here's one of the creations I made. I think this is when I was 12 or 13. It's a little owl. That was my first passion. A little bit later, I got into guitar playing. I was trained with music from much earlier, but I wasn't in love with it until I found the guitar. And then I really fell in love with it, and I dedicated a huge amount of my time to practice and furthering myself. And I actually ended up choosing my university based on the guitar teachers that were there on the faculty. The Romeros, which was UCSD. They're no longer teaching through there now, but I had the privilege of studying with them, even though it wasn't my degree. My degree was computer science, which I continued as long as possible to get my PhD. And During my studies in the university, even though I was playing guitar a lot and I was continuing sculpting, I still felt like I was missing using my hands to create stuff. And I had this longing to build guitars for a long time. And I contacted a few guitar builders in the area, and there are even schools that you can go to, but they're very expensive, and I didn't have much money. So I found a book about building guitars. I read it, and then I just went for it. I set up a tiny workshop in my bedroom, and I started building my first guitar. And it took me a year to do it. It was very challenging because I had to make a lot of the tools from scratch. But it was an interesting journey which started me on this lifelong endeavor, really. So I forgot to mention the definition. What I do, building musical instruments that are stringed, it's called a luthier, okay? Lutes are, if you've ever seen egg-shaped instruments with lots of strings, guitars, violins, cellos, that's the family of what luthiers build. I focus specifically on classical and flamenco guitars. The picture you see here in the slide is something from my research, which I thought would be humorous to understand what I used to study. It was basically trying to characterize the behavior of programs as they execute. Here we're looking at gzip and try to classify them into phases. And one thing you discover when you start doing this is that a lot of that behavior is repetitive and cyclical. And I kind of find that applies to my life and many in general, where I started with sculpting and playing guitar and engineering, and then I kind of went back to my roots of working with my hands and sculpting. And I still utilize a lot of my research, as you'll see in some of the slides. So let's get into a brief history of guitar. Guitar, the earliest predecessors are actually quite ancient, from Asia thousands of years ago. But one distinction about these instruments is that they were carved out of a block of wood, the body of it. So you took a log or a big piece of wood and just start hacking at it, creating a cavity, and you glue a soundboard over that. And you could still have frets back then. These were usually made out of tendon or something, and they're tied around the neck. And this is really the earliest form of guitar. But we start talking about used instruments today, we go into the vihuela. That's the true old guitar, starting from the Renaissance and Baroque periods. And in this instrument, what we have is a body that's created from thin plates of wood that were actually bent to create the form of the sides. The back was glued on, and it's much, much lighter than an instrument that was carved out of a chunk of wood. Acoustically, it behaves much different in how it vibrates and responds to the attack on the strings. So this is really where we start seeing things that sound more like guitars. Now, couple centuries ago, we have the romantic guitar, okay? And it's looking a lot closer to what guitars look like today. You see it's a little bit narrower. The main guitarists at the time that used it, Fernando Sor and Giuliani, they're like the Mozart of the guitar. These are the instruments that they used. But the biggest evolution of the instrument was done when a Spaniard by the name of Antonio Torres in the 1850s designed the guitar that we know today. Okay, this is the modern classical guitar. There was no distinction back then. It was just the Spanish guitar. The body was much wider, and some very interesting things were done internally with the bracing and the scale length to give you the instrument that we know today. So Antonio Torres is the father of the guitar, very much like Antonio Stradivarius is the father of the violin. And not too much has been changed as far as the looks of the guitar goes. Technologically, though, there have been some modern evolutions of the guitar, and if there's time, I'll get into that at the end of the talk. So let's get into the construction of it, or my approach. That's the important thing, the approach to how do you build a guitar. Well, there's a difference when you first do it and you just want to build a guitar for yourself, and when you do it professionally and you build it to sell it to a client. So now I have orders. People come to me. They don't have to be professional musicians, but a lot of times they are. And I need to understand very, very specifically what their needs are. And this varies across a huge spectrum of parameters. For example, there can be someone with smaller hands, and it's very difficult for them to play a standard-sized guitar. So they may need modifications in the length of the scale or the width of the neck. And these are all things that I can change and I can control as a luthier. Another needs are, for example, the sound of the instrument. There are people who like to play classical music, and there are people who like to play flamenco music, and there is a bit of a difference in that sound. The video later in the talk will demonstrate that, but all this has a huge impact in how I approach the building of the guitar before I even do anything with the wood. Once I understand the needs of the clients, the next thing, of course, is to select the materials. The materials that I choose will have a very significant impact on the sound of the instrument. So I brought a guitar here today that I recently finished. This guitar is built with a soundboard made out of Western red cedar. Okay, this is darker than the spruce. Spruce is the more traditional wood. It's a little bit lighter in color. This wood comes from Canada. The spruce comes from the Alps. The body of this guitar is made out of rosewood. Okay, this is rosewood from India, and there's rosewood from South America, there's rosewood from Africa. If I choose different materials for the guitar, it'll have an impact on the sound, as well as how I treat that material. So one of the important things at the beginning is to select the material specifically for the client's needs. What kind of guitar do they need? I brought a few pieces I'd like to pass around. This is actually cedar from like you see on the guitar here from the top. This is very light. It's considered a softwood, and it's light but stiff. Okay, so pass this around. Has a nice smell. This is a piece of cocobolo. This is actually from Mexico. The guitar I made for Barris is built out of this wood. It's extremely dense, extremely oily, has a very glassy sound. You guys can tap it. And right here, we have ebony. This wood is not colored or dyed in any way. This is the natural color of the wood. This is from Africa. It's very, very hard, dense wood. If you put it in water, it would actually sink. And we use this on the guitar where the fingerboard is, because this is where the fingers touch raw wood, and you want it to withstand the wear and tear of that. So I'll pass this around, and cocobolo. So I select the materials I'm going to use for the guitar I'm building for a specific client, and then I start building it. Okay, that's the construction process. The materials, I'll ask you guys a question. One of the most important materials in the guitar. It's up here. It's ridiculous to ask the question. So the wood is the most important thing, but just as important is the glue, and then the polish. Okay, these three things are what build a guitar. You combine, you glue together two pieces of wood with glue. And a lot of people think, glue, very simple. But actually, glue is a very, very complicated medium, material, whatever you want to call it, and, adhesive. But the different types of glues have a huge impact on the quality of sound. Some glues that are, let's say, soft and plasticky or foamy, okay, they're glues like that, like polyurethane glues that foam up. What happens, for example, contact cement is very soft also. When you got two plates vibrating, it's going to dampen the sound. It's going to absorb the sound and it's not going to transfer between the two pieces. Versus glue that's very hard and crystallized, which I'll talk about in a second, which would actually transfer the sound and the vibrations without absorbing it. The same goes for the polish. I put huge thought and labor into the polish of the instrument, and these three things really make a big difference in the quality of the instrument. And finally, the construction method. Okay, there's two things here, which is the design of the construction, doing a traditional instrument, kind of dimensions, the bracing that goes into the instrument, and then how you do it. How do you tool the work? Okay? So here's one angle of my workshop today. This is, you see some guitars in the background. They're hanging, I'm polishing them. You see here some soundboards that are already joined and just drying and seasoning. And I work on this workbench. This is where I spend my day. I usually stand there and do something interesting with the wood. Here I'm slicing a big chunk of wood. This is going to be shown later how I make the necks out of this material. This is Spanish cedar, quite different from the Western red cedar because this material comes from South America and it's much harder and denser than the cedar used for the soundboards. The tools. So the tools that luthiers use today are tools that used to be widespread in every woodworker's home. Let's say 50 years ago or a century ago, before power tools really took off. Unfortunately today, a lot of wood shops, you rarely see tools like this. People forgot the art of the hand tool. And I got two different types of tools here. Where's this thing? Here we go. So on the upper left side, you guys are looking here too, I got Japanese tools. And recently I found the beauty of Japanese steel. It's absolutely incredible. Versus here on the lower right side, these are Western tools. And here we got a couple of planes. Planes are used to shave wood. They have a knife embedded inside the tool, and you push it across the wood and you can get a very, very fine shaving. This is how you remove stock, and you can thickness plates of wood this way. And you got some chisels here that are Western chisels. The main difference in quality between the Western tools and the Japanese tools is in the steel itself. The Japanese have a long history of steel, can imagine with samurais. And the way they make the finest tools is by laminating a very, very hard piece of steel with a very soft piece of steel. And the guys that make these tools do very much what I do with the guitars. They're people who have spent their entire lives, a lot of times it's multiple generations doing it, just building tools by hand. And these tools, now that I've done this for so long, I can really appreciate them for their quality and incredible performance. So I don't want to say they're better than the Western tools, but there is much more of craftsmanship involved in creating them. The work, well, it's handwork for the most part. So once you thought through the specs of the design and you start building it, you put stuff together and then you cut it. So here I'm using one of the knives and I'm shaving the crest of the head. You got to learn how to sharpen the tools, and then you got to learn how to use them with control. And one of the big differences in the work from, let's say, from sitting in the computer and programming is there's no undo. There's no let's revert back to an old save. So if you do a cut and you overcut it, well, that's done. And the amount of focus you need to have when you do this work is incredible. You really got to be in the zone when you're doing it. So that's something that I really enjoy about it. The materials, I mentioned it before then. So the wood, and then there's glue and the polish. So the glue that I'd like to use, which I think is really the superior glue, it's the most traditional glue, it's called hide glue. It's animal glue, basically. It's cooked down from hides and bones. It's very similar to gelatin, and the way you use it is you melt it in water in a special glue pot that raises it to a very specific temperature. And when it's hot, you can actually use it. It's like honey. And you can brush it on the wood, and very quickly you gotta put the joint, rub it, and that's it. It's stuck. The beauty of the glue is that you can reverse it. You can heat it up later, open it up, and the important beauty of it is that it crystallizes super hard. It snaps like glass, so it's incredible material. The other material on the left side is the polish that I use. And this polish is called shellac. Okay? Shellac is a very interesting material. Used to be very popular maybe a century ago, but today largely forgotten. Basically, it's interesting to know its origins. It comes from the seedlac beetle in India that grows in a specific tree. And the beetle encrusts the branches of the tree with some kind of excretion from eating the resins of the wood and lays its eggs in there, forming its colonies this way. The people there in India, they flake this material off, clean it, from all the bark and bug pieces, and then you just melt it in alcohol. It's as organic as it gets. And the process of applying it, French polish, which I'll discuss later, provides the finest finish for acoustic instruments. So it takes a lot more work to do this polish than, let's say, spraying on lacquer, which is what factories do. But again, when we're talking about building something really, really good, you want to do the finest possible things. So we go down to these basic ingredients. Okay, so one of my jobs is also to find the best material. So before starting the guitar, you need to have good material, good wood. You got to start with good wood to build good guitars. And here's a picture of me selecting wood in the Alps. Me and my wife, I took her on a very exciting trip for 2 weeks to go drive around the Alps and visit people who specialize in cutting spruce trees specifically for musical instruments. And you see in the pictures here on the right side, these are tops for violins and cellos from spruce. This is spruce, by the way. You see the difference in color from the cedar piece. So we traveled, we looked for the best material, and once I found it, here I'm selecting it, I bought as much of it as I could afford. And the idea is to stockpile your workshop for your lifetime as a builder. The longer it's in your shop and seasons and ages, the finer it's considered. So I know my wife loves me very much. She sat on that table for 3 days while I was selecting through thousands of pieces. Let's start with the construction. So once I select, I have the material, I know what I'm going to use to build a guitar. I'm going to give you guys a very, very quick overview of basically every part of the guitar and how I build it, okay? So starting with the soundboard. The soundboard starts with a piece of wood that's been book matched, which means you take it and you cut it down the center and you open it like a book, okay? And then you join it, which means you shave it very, very accurately, and then you glue it with hide glue, of course. And ideally, you have no idea there's a seam. It looks like a single piece of wood. Well, what it gives you is a symmetric piece of wood, or 2 pieces of wood, that are going to react to humidity changes exactly the same. That gives you more stability in the top of the instrument. The back is treated the same way. Once we join the back, we're going to start thicknessing it, okay? And in the guitar building, this is one of the most important things that are going to determine the overall sound of the instrument. There are machines today, you can take a piece of wood and run it through the machine and get it down to exactly 2.22 millimeters or whatever thickness you want. But the art of guitar making or instrument making in general, is to take a piece of wood and appreciate its unique properties. Every piece of wood is different, even from the same log. So I got stacks of spruce billets, and they're all marked what tree they're from. And a lot of them are from the same tree, but a lot of them have different properties. The art of it is really to understand those different properties, and you're shaving it with the plane, and you really want to understand, I got to shave a little more here or leave it a little thicker here. You feel it with your fingers a lot, bending the wood, you can tap it. And this is really important because once you thickness the soundboard, you generally don't want to touch it. Once the soundboard has been thicknessed, the next step is to cut the sound hole and inlay the rosette. So this is the sound hole in the guitar, right here. It serves a very important purpose, okay? The sound of the guitar doesn't actually come out of the sound hole, which is counterintuitive. The sound hole serves the purpose of allowing air to come in and out. Essentially, it's like a pump. The sound comes from the soundboard here, which is moving when you're playing the strings, and this is causing the air to move, and that's what you're hearing from here. This is just allowing this wood to not create too much of a vacuum, okay? That's its purpose. The rosette, the purpose of the rosette is to reinforce the sound hole. And it can be done very simply with a single piece of wood, or when you're looking at very artistic, high-level instrument, this is really the artistic signature of the luthier. And this is where handmade really gets handmade. So designing these rosettes, you can spend a lot of time and thought into it. And when you know your guitars, I can just look at a rosette and know who built it, whose guitar that is. So just to briefly show you the process, you start with the center motif, okay? There are little tiles, and each tile here has maybe 100 little squares of wood, like pixels, okay? And you glue them, okay, around a circle to get the design, okay? That's the center motif. Once that's glued, you dig different channels for the borders, and then you glue in the borders. The reason I do it in different steps like that is because the rosette is a very complicated piece to inlay. And I can say from research or just doing this, I've learned to break complicated procedures, you break it down into subtasks that are a little less complicated. And what that gives you is a little bit more control and at the end, finer quality. So you can see I'm gluing it in here. Here I'm shaving the rosette. And you can see the pixels of a very close-up photo of the rosette there, the little squares of wood. And also here. So I have two different designs. It's really the artistic side of the instrument. You can play with many different designs. You can spend endless hours here. It doesn't have any impact on the sound of the guitar, but this is part of the artistic part of it. So that's the rosette. Once the rosette is finished, I flip the soundboard over and I start thinking about the acoustics of the soundboard, the guitar. Okay, and this is where we start constructing the guitar. Okay, the soundboard is supported with braces, and Torres, it was done sparsely before him, but he's largely considered the founder of this, the fan bracing system, where you take, these are the fan braces, sticks, basically, made out of spruce. You glue them onto the soundboard, and what it gives you is a very controlled manner in which the soundboard vibrates, okay? A much more subtle but yet important thing that it does is actually, if you carefully look at the soundboard of fine guitars, they have a bit of an arch to them. And these braces actually create that arch. It's glued in a domed dish called a solera. And the gluing process, you can see with these sticks, the thin sticks that are sticking vertically, they're not the braces. These are called go bars. Go bars are the clamps. They are sticks that are basically bent and flexed, and they can be resting against the ceiling, okay? And then they can apply very fine pressure, let's say a couple pounds, directly down on a single point. So I can use a few of them to glue each piece of wood down, and don't have to deal with clamps. It's a very primitive method that was actually developed by harpsichord makers centuries ago, and it's a great method to use. The fan braces, once I glue them, I shave them, okay, with a little plane and chisels. And again, this is done by hand. You can try to come down to precise dimensions, but the best quality usually comes from some kind of intuition you build in your fingers. So where to stop, it's a matter of gut feeling, and that's kind of how you see it here. And here I'm just flexing and looking at the soundboard to gauge how it's going before I continue on in the building process. So the soundboard is by far the most important part of the guitar. Selecting good wood, the design, and then finally the intuition of the builder into bringing out the qualities of the wood are going to have a huge factor in how the instrument turns out. The neck. That's this part here in the guitar, right here. This is the neck, and it starts out with, you saw that giant piece of wood in my workshop. I was sawing it. That is called Spanish cedar. It can also be done out of mahogany. So I cut it from a big billet, and then I get it into a smaller piece of wood, and then I start shaving it with the planes. You see all these shavings on my workbench. The planes don't only reduce the dimension, but they make it very, very flat, okay? And you cut special joints to glue the head on. And what's being glued on here is called the heel block. I'll show it in the next slide. The heel block is one of the big distinct features, between the Spanish style of building and the American style of building guitars. Okay, so you see that big block of wood here in the picture, which I carved down later into what's called the Spanish foot. And the American style of building doesn't have the foot. What it has is you build the body of the guitar and you build the neck separately, and later you join in with a tenon. Okay? The Spanish style, you have the Spanish foot, which is integrated into the body. You build the body of the guitar around the neck. So the sides are actually slotted. They're not glued into the neck, they're just wedged into it. And it's much more integrated. And I believe, for me, it's worked much better. So this is the method I use. So the photos aren't exactly chronological, because here you see the body, the guitar already built a little bit. But the neck, just to show you the finishing touches on it, you got to carve it. It started out as a square piece of wood. How do you carve it? So this tool you see here with the red handles is called just a pull shave. It's a knife with two handles on it. It's a great tool, and you basically pull it, and it gives you a nice shaving of wood. Of course, the skills involved in using it will determine whether you destroy the guitar or not. Initially, when you don't know what you're doing, you're going to be using a lot of files and rasps and sandpaper, but as you get better and better and better, you can actually start using more and more edge tools. These are things that shave the wood and actually are faster and give you a much higher quality finish. So you can see how I do some of that process here. So let's talk about the body of the guitar now. The body of the guitar is basically, in this case, I'm talking about the sides and the back, okay? And in this photo, just like this guitar, it's rosewood, okay? Rosewood is a dense, heavy wood. Comes from all around the world. You have it in Asia, India, which is this material here, South America, and Africa. And you see the back here and the sides. The sides start out as two strips of wood. They're also book matched. Everything in the guitar is book matched. So it started out as a single billet, and it was sliced open so that they're symmetric. And the way they react to the humidity will be symmetric. And here I'm bracing the back. Okay, I use the same Go bar deck. I use the hot hide glue. You can actually see the pot of glue here in one of the photos. Let's see if you see that. That's the hot pot, and I use a syringe. It's sitting in a bath of water that's heated to exactly 150 degrees Fahrenheit. Right here. Where's the light? I can't. There it is, right there. And you can see the glue squeezed out here. The beauty of this glue is after just a few seconds, as soon as it cools down, it gels. Okay, it is like gelatin. And you can take a little scraper and just scrape it off, and you get this nice long kind of gummy worm, all right? And we used to have a dog. I used to feed my dog this thing. She loved it. But now I have it all over the shop. So you brace it, and you shave it, and here you see me bending the sides. The traditional method, of course, is doing it on a hot pipe. And you take the sides, and when you apply heat and pressure to wood, if it's thin enough, it'll bend. Okay, it kind of plasticizes. So sides that are around 2 millimeters thick, you can actually bend them. Again, the skills involved are to avoid putting too much pressure or trying to do it too fast, which will cause it to break. Or if you do it too slow, and the wood will burn. It'll start smoking and you'll get charred wood, which is very bad. So back and sides. A slight digression here in this slide, just because it is Google here. So where did I use some of my skills with computers is in designing a bending machine that would bend the sides for me. Okay, this is done in many shops. It saves time. The problem is that when you bend it in a machine, you usually use a heating blanket or some kind of heat source. Whatever you do it in, when you pull it out, it springs back. Okay? So the idea is to overbend the shape of the sides so that when you pull it out of the mold of the machine, it'll spring back to the final shape that you want. Okay? So my idea was I'll take the shape of the sides and I'll overbend it by a specific percentage. Okay, so I wrote a small program in MATLAB. I entered the coordinates of the sides by hand. That actually took the most time to grid it out and measure that and put that in. And then I created a program that will basically increase the angle between each two vectors by a certain percentage. And you can see here, I can't see, but there's the default is on the bottom. That's the original side shape. And then increasing it by 10%, 25%, 50%. And then we jump up to 500%, and it gets very noisy just because it was measured by hand. And the idea for me was to try a few of these different curves to see which one would give me the closest shape when it comes out of the bending machine. Well, unfortunately, it turned out that this was useless because every piece of wood reacts differently to the heat, springs back differently, and basically the machine will get you close but not there. So you always do it by hand at the end. It still saves time, that's for sure. But I did have an excuse to program a little bit. I can show it here. All right, so here's the open guitar before I glue the back on. So you can see the architecture of it. It's actually quite interesting if you're a structural engineer to understand, to see what's going on here. A lot of it is structural. There's very little unnecessary pieces in here. The fan bracing, in this picture you see an additional brace here which is called a treble bar right here. It goes at an angle across the fan braces. What it does is it breaks the symmetry of the braces, kind of forming it more like a piano. If you think of a piano, it has different lengths of strings, and this is kind of the idea here, to break the symmetry. You see all these little blocks of wood glued around the perimeter here. These are called tentelones, okay, and their purpose is to attach the sides to the soundboard. Each one, you pick it up with a little needle or tweezers. You put a couple drops of the hide glue and you stick it in there, hold it there for a few seconds, then you go to the next one, and it's actually very meditative to do this part of the process. I really enjoy it. And a lot of people have never seen guitars from the inside like this. It's really beautiful. And the next step of it, of course, is to glue the back on. So that's done like this. This is a very traditional method, roping the back. So you basically wrap rope around it. I found that surgical tubing works really good here. So that's what I'm using. And you can let it dry. And once it's dry, take off the rope, and you have something that looks like a guitar. It doesn't sound like a guitar yet, though. Not even to me as a builder that can hear the wood. That's going to come after this step, the bindings. The bindings are really, really important for the guitar. They serve a structural purpose, or functional purpose, I should say, in that, if you can see it, it's a strip of wood that's glued around all the perimeter of the guitar. It seals the end grain that you see exposed on the back and on the soundboard. And this is very important with wood, to seal the end grain so it doesn't react to changes in the weather, in humidity specifically. So the way they're done is you carve a channel around the corner perimeter of the entire instrument. There are two of them, actually. There's the binding, and then there's the purfling, which is slightly smaller, and you bend them to the shape of the guitar, and then you glue them in there. This is actually quite a tedious, a little more difficult part in the process of building. And you can see here how I'm gluing them in with a special roping method. So I ran out of tape one day, and this was the method I was used to just use tape. It's very, very simple. You just start at one end, you put some glue and you tape it on, and you keep going. But you need good tape, you need strong tape. And I couldn't get any, it would take me a while to order it. So I built this jig, which allows me to use rope. And it actually gave me a lot more control, and a lot more control in the pressure to glue it on. So you can see how I'm roping it, going from one end of the instrument to the other. And it just sits there for a bit until it dries, and then I can do the other side of the guitar. Once the bindings are done, I can shave them, and then I can finally hear the quality of the instrument. The reason for this is that the bindings, aside from sealing the end grain, they actually change the stiffness of the joints from the sides to the back and the sides to the soundboard. So they release some of that tension there. They open up the instrument, and if you tap on the soundboard, you can finally hear the instrument responding in the way it's going to be towards the end of the build process. So for me, this is one of the most enjoyable steps. Scraping to see the beauty. You gotta cut all these joints. These are miters here at the tail. We're talking about something that's less than 2 millimeters wide, and you get one shot at cutting. I can't see the red. There it is. The miter there with a chisel. And if you mess it up, that's how it's going to show. There's not much you could do about it. So that's the bindings. Once I'm past the bindings, I have a little bit of a breath out. It's like, ooh, that was hard work. And we move on to nearly finishing the instrument, actually. This is the fingerboard now. There was a piece of ebony. It's on the floor there. I passed it around. That's what the fingerboard is made out of. Yeah, it's the ebony. This is the piece right here where we glue it on the neck, and the frets are going to be installed in it, and it needs to be very hard wood to take a lot of punishment from the fingers. So here I am starting to plane the fingerboard, and that took me some time to learn. You need very good tools. It's such hard, abrasive wood. You really learn to appreciate quality steel. So this is it becomes a joy to work once you have good tools. So here you can see how I'm gluing the fingerboard. And once it's glued, I can start slotting for the frets. I use a saw for that. So the frets are spaced. It's very carefully determined their location. If they're not accurately spaced, you're going to have a problem with intonation and you'll never be able to play in tune. So it's critical to get this part right. And the frets themselves are basically pieces of nickel metal with a tang on them. You hammer them into the slots, you've cut them flush, and then the detail work is really in getting the leveling of the frets down. So they're not perfectly flat. In really fine instruments, you really want to find a very special bowing in the relief of the frets. And there's some technical stuff in the back buzzing of the strings and the size of the wave of the string, depending on what frequency it's on. 10 minutes?
You can keep going.
No, it's all good. Thanks. But here, really, my years as a player gave me a huge advantage because I could really appreciate an instrument that was done right for the playability of it, meaning comfort. You want to have the strings as low as possible without exerting yourself too much. And the way you achieve that is by getting this part done right. So once the frets are done, you can enjoy looking at them. And you'll notice how they're not spaced equally, but rather the space is getting smaller and smaller and smaller and smaller. Okay? So that's a mathematical definition of how to distance for a 12 note scale. And the last assembly process is the bridge on the guitar. The bridge is basically, it's called the bridge because it's bridging the strings to the soundboard. Okay? It's going to transfer the energy of the vibrating strings, and it's actually a torque mechanism. It's different from the violin or archtop guitars. The way the bridge works on the classical guitar and acoustic guitars is there's a big saddle here, and the vibrating strings, they pull in the bridge and they cause it to move like this, okay? And imagine the torque it applies is this kind of movement on the soundboard. So it's not just this, but this, more like this. The heights, the dimensions of the bridge are very critical in the overall resulting instrument. So it is said that the great Spanish makers used to start with the bridge and build the guitar around the bridge. And you got to put a lot of thought into how the bridge is designed. For example, the difference between a classical guitar bridge and a flamenco bridge. The instrument might be exactly the same, but if I change the bridge, it will cause a big difference in the sound. So the bridge is made out of a hardwood, in this case Brazilian rosewood. It's similar to Indian, just a little bit denser. I get to put my flourish on there. It's not redundant though. You need that up there. It's called a tie bar because that's where you tie the strings. And if you see those two strips of white there, that's made out of bone. They actually give you that hardness which the strings would eat through otherwise. So you need bone there to strengthen it. Another little cute innovation is it's done today. I didn't invent this, but I like to use it. It's called a 12-hole bridge. A 12-hole bridge allows you to feed the strings through the bridge and not to have to loop back and tie the string on itself, which would raise the angle of the string across the saddle. It increases the torque angle or the break angle on the saddle. So especially with flamenco guitars, it's very important to do this. All right, so the bridge, you got to design it. The dimensions are important, but the most important thing is to measure its location. If you don't glue it in the right place, you're going to be screwed because the guitar is never going to be in tune. So here you can see measuring it. The distance of it is going to determine the scale length of the instrument. Okay, 650 is the standard scale for classical guitar. You can play around with that, 640, 660. Once you measure it and you know exactly where it's going to be, you glue it. and I glue it with clamps. I mentioned before there's a belly or an arch to the top of the guitar. Okay, so the bridge is actually built with that arch to it. And when you glue it, you want to make sure you maintain that arch. So underneath, inside the soundboard, there's a piece of wood with that arch built into it. And this is how you glue the bridge on. You can see it from a different angle here. And this is really the last part of the assembly of the guitar. And we're not done, because now there's the French polish. And a lot of times, I will start a guitar to build it and finish making it, and then I'll start polishing it, and by the time I finish polishing it, it'll be the same amount of time as it took me to build it. The French polish process is very, very labor intensive, takes an incredible amount of time, and basically it's the technique of taking shellac, which has been melted in alcohol. I described it comes from India, from the special beetle there, and you see it in the bottles here in the picture. The materials are very simple. It's shellac, you have a pad. Pad is just an old piece of cotton t-shirt with some cheesecloth wadded into it. And then the other ingredients are oil and more alcohol. And those three ingredients and the pad are all you need to do French polish. The skills involved take decades. And I've been doing this for over 15 years, and it's still something I see myself learning for a long time. It's one of the difficult things to master. It's almost never done today in any wood workshop, except for the finest restorers. It was done in king's palaces to do fine furniture, but acoustically, it creates the finest finish for the guitar in the way it sounds. The reason for that is with the pad, you're actually applying thousands and thousands of microscopically thin layers. It creates a very thin but hard layer of shellac that's built in the guitar, and it doesn't dampen the sound, it actually makes it louder. A lot of guitars that are sprayed with lacquer from factories, it's like taking a nice something vibrating piece of wood and then spraying plastic over it, and then that kind of dampens the sound. It doesn't sound as good. So this is really the reason to actually invest in all that extra hours of work to do this. So here you can see guitar as I'm polishing it. This here is called a pounce bag of pumice, because the wood, if you looked at it closely, is full of little pores, and you got to fill them up. So before the French polish, the initial step is to fill the pores, and you rub pumice. It abrades microscopic fibers, and you feed them into the pores until they're leveled. Again, it's one of these things that takes decades to master, but the beauty you get with it is unparalleled with modern finishes, I would say. So I think I'm getting there. So here's a finished guitar. This guitar is a little bit fancier. For the purflings, I did what's called herringbone, or you can call it wheat pattern, going all around the perimeter. And here's another one that I did. This guitar is built with cypress for the body. It was still a classical guitar. It's much lighter though. It's more of a traditional style Torres guitar. And it had a strip of Brazilian rosewood on the back. Again, slightly more ornamented for the purflings. And now we have a little treat. He's my friend, but he's a great guitarist. He's a client of mine, Adam Del Monte. He's actually living in Los Angeles. He's a fantastic flamenco player and a fantastic classical player. It's very rare to find someone that has mastered both of these fields. And he teaches down there at USC and performs all around the world. If you get a chance to see him, that'd be highly recommended. I'm just going to play it.
Hi there to everybody at Google. My name is Adam Del Monte, and I am happily and proudly playing two of Erez Perelman's guitars. This one is a classical guitar, and so it is designed with warmth and sweetness in mind, and it's got plenty of it. sound just keeps sustaining. It's makes you drunk, because every sound that you play, you want to play another one. That's the secret of a magical guitar. As soon as you play one note, you don't get quite enough of it, so you need to play another one and another one. This is the sweetest instrument I've ever played. Expressive. As opposed to this guitar, which is a flamenco guitar, and it is called a blanca because the back and sides are made of cypress. It is a white wood. The top is also spruce, and it is designed for speed. So this would be your Ferrari in the garage. Designed to have a very fast response. It has a percussive sound, and the magic about this guitar is that it just melts into your fingers and allows you to do whatever you want, kind of like a Ferrari. So Erez, you are the greatest. Thank you.
All right. Yeah, that's Adam. And that was the last slide. I want to open up to Q&A now. If anyone is interested, I have a website with lots more info. So thank you very much. Please.
I'm curious, you use the Japanese chisels, but you use Western planes, which are pushed rather than pulled. And I just wonder if you tried that, the pulling one, and if there's a difference in the woodworking style.
Yeah, I have Japanese planes too. They're a little more finicky to set up. There's no adjusting rings on them or screws, but the steel is definitely superior. But you know, it comes down to the tool that does the job best. And I find the Western style adjustments allows me to get there with planing. With the chisels, it's a different story. I want an edge that's going to hold as long as possible. So I like to use the Japanese chisels there. I have Western chisels that are great too, depending on the wood I'm cutting. A lot of the tools are specific for a single thing that I'm going to use them on. So it's really finding what it's for and then learning how to do it the best way there.
So as a past life as a researcher, you probably like spent a lot of time thinking about how to do new things in new ways. Have you thought about like new ways to do bracing or like double tops and all sorts of stuff like that?
Yeah, that's a great question. So it's interesting. When I first started building guitar, I was convinced I'm going to invent the best guitar that was ever built. And I thought about it for a long time, and I came up with this crazy design called the prism guitar. And it was crazy, it was insane. It turned out beautiful, but after the years and years and years, I realized the tradition, respecting the tradition, the centuries that people tried different things and what survived, there's a lot of things to learn from that. Today there are double tops. Double tops are guitars that are designed with volume in mind. Basically, you take the soundboard, which is a 2 millimeter thick piece of wood, and how do you make it even lighter? So what they do is they hollow it out and stick something synthetic. It's called Nomex in a honeycomb fashion. This is coming from aeronautical and space engineering. You can cut the weight by half, get a much louder guitar. And I've done it, I've experimented with that. But I believe the quality of sound is compromised with that kind of guitar. I'm a very strong believer in the solid wood traditional style of instrument. I do have two pictures here, though, to show some innovation that has been done with traditional guitars. These are still traditional guitars. So on the left, you see a guitar with a hole in the side. It's crazy, but it's very popular today amongst players. It's called a sound port. What it does is it gives the player a bit of that sound. It's throwing it in their face. And this is especially important for people who are playing with a big orchestra behind them, or if you're playing with an accompaniment, you know, a few people. And then you really want to hear yourself. So this really gives you that ability. Additionally, it's hard to make out in that photo. It's an elevated fingerboard, okay? The fingerboard is raised above the soundboard to give you a lot more access to the higher notes. It makes it an ergonomic feature, more comfortable to play up high. The guitar you see on the right side is an incredible guitar. It's called a Brahms guitar. One of my favorite players ever is called Paul Galbraith. And he developed this guitar with the late luthier David Rubio from England. It's essentially a guitar that has fan frets where every string has a different scale length. Okay, if you notice that, the bridge and the nut are different angles. So the bass and the trebles have different lengths. And I had to write a program to compute the scale lengths on this guitar too. What's incredible and special about this instrument, normally when you have more than 6 strings in a guitar, it's extra basses. So you add basses, 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 and it's very easy to control them with the thumb. It doesn't open up a lot of the range of the instrument. In this guitar, you actually add a treble. So there's one extra treble and one extra bass. So it's opening it up from both sides. It opens up a whole new body of music that couldn't be played on the guitar before. To be played. It is a difficult instrument to play. You play it upright like a cello. It has an end pin that goes on the floor. So to answer your question, there is experimentation within tradition. And today I continue experimenting, but my experiments are much more focused on a tenth of a millimeter thing, you know, very, very fine adjustments, where I'm looking for something very consistent, but to improve it and finding which way to wiggle the curve to achieve finer and finer instruments. Also, to a lesser extent, but just as important, I have clients with special needs. For example, clients that have injuries in their backs or shoulders, and one of them asked for an adjustable support system of the guitar that could lay on the floor, and could be angled and raised to any angles. You can even stand with it. So here I built him a special a support system out of a monopod, basically like a camera monopod. And that's one of the benefits of you're building every guitar for the client, and it might encompass something like this, and the support systems too, specifically for their needs. I don't do a cookie cutter approach where everything is exactly the same, take it or leave it. So it's a very feedback oriented process, and the research is done within a very controlled manner.
Did you get a chance to look at the work that Adrian Houtsma did, like in 1975, 80, on guitar acoustics?
The name sounds familiar. I used to read a lot of the, GAL publications. Did he do the round bracing? The circle bracing?
The bridge support.
Bridge support.
So it was, basically, you can make the face a little thinner if you prevent the bridge from rotating with a separate support.
Yeah. Specifically, no, I don't remember his research, but every builder researches to some extent. A lot more here in America for some reason. It's the land of cowboys here. And it's very interesting to see what people are doing. Again, I'm a very strong proponent of the traditional build for the special reason that I had the opportunity to play those guitars made by Torres. This is a very rare opportunity. If anyone plays guitar here and they have a chance to play a historic instrument, the sound is really magical, and it's impossible to portray it on recording. You really have to try it out to appreciate it. So I'm open-minded. I'm always looking, considering new things. But to me, the ideal sound is still coming from that traditional design. And I'll always look for better. But right now, that's the ideal for me.
If it's public, how many instruments do you build every year?
Sure, it's very limited. Each guitar takes me over a month to build. So I'm building around 10 to 12 guitars. And this is generally the output of luthiers doing guitars at the top level without trying to expand and scale the shop with helpers or big machines. So I'm not trying to build more guitars. I'm trying to improve the quality of each one. And the French polish, as I said, that takes a huge amount of time in the build process. So that limits really how many guitars you can make. Thank you, guys.